So today I'm going to be talking about Guiyu, China, which is known in the early 2000s as a recycling hub for electronic waste. The objectives of this discussion are to define electronic waste, to compare electronic waste production across certain global regions, to ascertain typical forms of electronic waste, to determine the severity of electronic waste as compared between two towns, to examine effects of the recycling process on human development, to ascertain the severity of e-waste in Guiyu, China's neighboring ecosystem, and to explore how the problem has improved or worsened over the years. So expanding off of our objectives, we're going to go over what is electronic waste and how is it recycled, and then the figures will be indicating data that sort of helps to facilitate this discussion, such as e-waste production by region, common types of e-waste, prevalence of e-waste byproduct lead in two different populations of children, e-waste byproduct lead effects on developing children, and prevalence of e-waste byproduct PBDE in Guiyu waterways. So what is electronic waste and how is it recycled? Electronic waste covers an array of items. Some that you might be thinking of include cell phones, wires, old phone chargers, computers, microwave ovens. Others include air conditioning units, heating units. Pretty much most electronic items that you might think of probably fall under the umbrella of e-waste. In Guiyu, the people tasked with stripping these parts tend to be impoverished and they needed the work to survive. So in order to break down these complex items, they would use acid to extract precious metals such as silver and copper, and they would melt keyboards and other plastics over open flames in an attempt to reduce them to their smallest components. However, as one might guess, this method of recycling caused a huge amount of toxins to be released into the air and the rest of the environment. So, e-waste production by region as of 2014, Asia was the highest number of million metric tons per year at 16. Europe and the Americas were relatively tied with one another, and they fell second in place to Asia at roughly 12 million metric tons per year. So according to a UNU report, Asia, as we just discussed, generated the most e-waste at 16 million metric tons. In 2018, China passed a law banning Western waste from being imported into the country. Up until this ban, however, roughly 80% of American e-waste was being imported to China for recycling, most of which made its way through Guiyu as a central recycling hub. So if we were to calculate the amount of total e-waste that was being imported to Asian countries, in addition to what was already produced, that would add up to roughly 25.3 million metric tons of e-waste in 2014 alone. So some common forms of e-waste are large equipment and small equipment. When you think of small equipment, you might think of cell phones, associated items. Temperature exchange equipment would be air conditioning units, heating units. Screens and monitors are referring to computers naturally, and then small IT and lamps. So e-waste prevalence with lead as a case study. So this information was gathered in a 2007 study, and it was comparing blood levels in children from Guiyu and a neighboring town. So as you can see, the blue line refers to Guiyu, and children aged 1 to 4 years old had roughly 13 micrograms per deciliter of blood. So for the record, any blood lead level that is above 10 micrograms per deciliter is considered to be detrimental to a child or to anyone's health. So when comparing these numbers, it's rather shocking comparing 5 to 6-year-olds between these two towns. In Guiyu, they were roughly 16.5 compared to 10.27. So the effects of lead on neurodevelopment, obviously this schema is a little bit confusing, but essentially the solid lines refer to known health effects from the certain substance in question to the somatic effect. So for example, when you're looking at lead is directly known to cause oxidative stress. Mercury is directly known to interfere with calcium signaling. So the dotted lines refer to likely associations that are not yet confirmed. So even though they are not yet confirmed, it doesn't mean that these should be discounted. So lead is not yet confirmed as affecting epigenetics. However, it's still something that is really important and needs to be considered when thinking about blood lead levels, especially in children. E-waste prevalence in local waterways. So this was in the Nanyang River, which is near Guiyu, China, and the substance in question is polybrominated diphenyl ether, which is a byproduct of plastics and is known to be difficult to get rid of naturally, and it covers sediments in rivers very well, which is evidenced by this shocking number of 16,000 nanograms per gram of PBDE in sediments. The water snake is one of the prime hunters of the Nanyang River, and it's obviously also being adversely affected, and carp are a food source for surrounding towns, including Guiyu. So the Chinese ban on e-waste importation comes naturally with both pros and cons. So the pro is that this is helping to facilitate the cleanup of Guiyu after it was used as a e-waste recycling hub since the 1990s. So while they're addressing this cleanup and helping to rectify the damage that has occurred in the environment, the importation crisis has simply relocated to another country, Thailand being the primary, but Laos being another. A particular factory in the Samut Prakan province of Thailand was receiving significant amounts of e-waste, and nearby farmers were starting to become concerned because they were farming shrimp and they didn't want the chemical runoff to adversely affect their farming. So recently, Thailand has cracked down on both legal and illegal importations of e-waste from primarily Europe and the Americas, because they are attempting to get Europe and the Americas to take a look at their own production of e-waste instead of sending it abroad to lesser developed countries that need the money that is associated with recycling these items to actually process them domestically, which would cost more money, which is why Europe and the Americas have been sending it abroad up until this point. So the summary, again, is we discussed what e-waste is. We discussed how it's commonly recycled in Guiyu, China. We discussed the amount of e-waste produced by certain global regions, common forms of e-waste, lead prevalence as a case study in children of Guiyu and nearby towns, effect of e-waste on child neurodevelopment, the prevalence of e-waste byproducts in the Nanyang River near Guiyu, effects of the Chinese ban on e-waste, and finally the conclusion.